Welcome to lesson 2.5, solve equations with variables on both sides. Now, the first thing I'm going to tell you with this is anytime you see a subtraction, change it to adding the opposite. So in this first question, we have a minus 8x. Let's change that to a plus negative 8x. And we have a minus 17, so let's change that to a plus negative 17. The reason being is we're going to be doing a lot of moving around from stuff from one side of the equal sign to the other, and you need to make sure you don't lose those negative signs. And it's a lot easier to do that if you actually draw the negative sign out, as opposed to trying to leave it as a minus. So the first thing that I'm going to now suggest after that is let's get all of our x pieces onto the same side. So let's, let's go and just add a positive 8x to both sides. So that will cancel out the negative 8x here. So we'll be left with 7 on one side and 12x on the other because we have common terms. Now, let's go and get that negative 17 over to the other side. So that means you'd have to add a positive 17 to both sides, which would get us a 24 equals 12x. Well, now we can divide both sides by 12 to get x by itself, and x is going to come out to be 2. That wasn't so bad. Let's try another one. I know last time when we did this, I got rid of the fraction first, but now I'm seeing that we're having this minus here, and it's making me question if it's easier to get rid of the fraction, just distribute it. So let's just try distributing it first this time instead. So 16x times 1/4 would be the same as dividing it by 4. So 16 divided by 4 would give us 4. So it'll come out with a total of 4x plus 1/4 of 60 would be 1/4 times 60, or 60 divided by 4, comes out to be 15. On the left side, we still have a 9x minus 5. And now, excuse me, now I want to get all of our x's onto the same side. So I'm going to go through and I will subtract our 4x from both sides. And actually, since we're moving our x's to the left side, let's get our whole numbers to the right side. So I'm going to go and add 5 to both sides to cancel that part out as we cancel out this part. So 9x minus 4x will get us down to a 5x, and 15 plus 5 will get us to 20. We can now divide both sides by 5 and comes out with an answer of x equals 4. Ooh, this looks like another word problem. Let's go ahead and read it out loud quick. So a car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing on average by about 6 cars each year. The number of used cars sold by the dealership has been decreasing on average by about 4 cars each year. If these trends continue, in how many years will the number of new cars sold be twice the number of the old cars sold, or the used cars sold? Oh, okay. Well, let's think about it this way. So we're at 78 now, and we are adding to that 6 new cars each year. Let's just call the number of years X. And that will be the total number of new cars. So we'll just call this new. Our total number of used cars is currently 67, and it's going down by 4 cars each year. And that's the number of used cars that this place sells. So our question is, when will the number of new cars be twice the number of old cars? So what we can do then is we can just take our number of new cars and set that equal to twice the number of used cars. Now I've got an equation that we can solve. So let me just change my pen color quick. So first thing I'm going to do, I'm going to just distribute this 2 into both parts. So we'll still have the 78 plus 6x on the left side, but on the right side we'll have 2 times 67, which is 134, minus 2 times 4 is 8x. Now we can go ahead and rearrange this to get all of our x's on one side and our y's on the other. So I will go and add a positive 8x to each side to cancel that part out. And I will also subtract 78 from both sides to cancel this part out. Now we can go and combine our like terms. So 6x plus 8x gives us a 14x. And on the right side, 134 minus 78 comes out to be 56. Now we can divide both sides by 14 to figure out how many years it will take. And our total number of years in this case comes out to be 4. Well, that's pretty cool. Now, the next thing that your book wants to talk about is, that's why it said identity, is if a solution is actually an identity. What that means is something is equal to itself. So you might come out with an answer that says x is equal to x, or 2 is equal to 2. Or your question might even look at the beginning like a 2x plus 3 equals 2x plus 3. If it always matches like that, you don't just have one solution, you have infinite many solutions, because at every value, it will still come out to be true. It will still be the same numbers. This does not mean there's no solution. No solution means you're going to come out with something like 2 equals 5. And that is never true. 2 does not equal 5. So that is not an identity. An identity means there are an infinite number of solutions. And instead of having to write out infinity or anything like that, you can just say identity. And that is actually a more helpful answer than anything else. So the other piece of that is you will now see things that say solve if possible. That means if there is a possible answer that's just one answer, you'll put that. And if not, then we'll see what happens. So looking at this one, let's start out just distributing that 3 into both sides. So 3x plus 12 will equal 3x. And now we can go and subtract our 3x from both sides. We come out with an answer of 0 equals 12. Now you know 0 does not equal 12. So this would be a no solution, because you know that that is not a true statement. But let's try this other one. 2 times x plus 2 times 5. That will give us a 2x plus 10 equals 2x plus 10. Well, you might notice right away that this is already an identity, because it is 2x plus 10 equals the same thing. So you could just go and write identity at the bottom, and that would be enough. You have shown me enough work. Or you could still try to solve this and see what happens. So let's go and try and, actually, let's go and subtract our 2x's first. Try to get them out of the same side. So minus 2x minus 2x. Come out with a 10 equals 10. Well, we know that's true every time, so that's an identity. Another way you could go about this is subtracting your 10s to the other side first. And then we're left with a 2x equals 2x. You can divide both sides by 2, and you're left with an x equals x. That is also true every time. So that's what an identity looks like versus one where there's no solution. So that's all the more there is to this lesson. If you have any questions, make sure you shoot me an email, and otherwise, good luck.